Hey everyone, welcome to kind of part two of today's lesson. And the first few activities here we can, for the most part, complete independently. And while they might seem repetitive, I do consider them, quick enough and important enough to tackle. So here this is just going to be kind of our start. So on this particular packet, so it should immediately follow those problems. So there's a warm-up kind of quick activity that we can take a look at doing, and I'll have uploaded kind of the complete correct answers there, so if you want to check those. So we're going to tackle that. In Desmos, there's a little mini investigation where I'd like you to kind of follow the directions here and talk about, answer the questions as they're provided. And it's getting to the point where we're going to need to start specifying if we're in degrees or radians. So for this particular investigation, I want you to be in degrees because it's kind of designed for that. And know how to adjust the window and things like that. So if you need to kind of pick up on that, it's kind of worth exploring on Desmos to make sure that we can do that stuff. So you're going to complete this investigation, which again I'll have the answers for, and then this is kind of where I'm going to start chiming in just to make sure that we all have the same knowledge. So you can pause the video and do the first few pages if you'd like, or just kind of join me here and then go back and finish, and that's totally fine as well. So this is the basics of periodic functions. So, primarily this is going to pertain to sine and cosine. There are some other trig functions as well that are related, but my main lens here is with sine and cosine. So I have different ways to transform my function, and from what I've seen is these a, b, c, and d values directly impact certain properties, and it's even a little bit more accurate than that. So this a value is my amplitude. So it's a straight up 1-for-1. If I have y equals 5 sine of x, then my amplitude is 5. So I can directly put that value in should I know it. Similarly, and I'm going to jump around to kind of the really accurate ones, this d is my midline. So again, if I can see that a sine or cosine graph has a midline at 4, then I know that my d value is a 4. That had to take a vertical shift to get there. C is something that I think we had explored or we had taken a look at, and this is going to move things left or right. So this is a phase shift left or right. Kind of is what it sounds, moving something left or right. This can get tricky. For the most part, it operates like our basic transformations, but when we bring the period into it, it might look like something has shifted to the right, even though it's shifted left. If we take sine and we actually, if we take sine or cosine and we move them to the right by 2 pi or 360 degrees, then you really can't tell that I've changed my graph at all. And then finally is this b value. And again, ideally we've done the investigation on the prior page, but we can say that this is related to the period in that our new period is going to equal 2 pi divided by that b value. Or if we're talking about being in degrees, then it's 360 degrees divided by that b value. And it's important to realize that this 2 pi is solely because we're talking about sine and cosine, right? The basic period of sine and cosine is 2 pi. So when I have a b value of a 2, it means that those graphs are going to complete in a period that's twice as fast as what it previously was. So if I do 2 pi divided by 2, then I end up getting that my new period is only a pi. Or, if I'm in degrees, sine and cosine normally have a period of 360, But if I'm dividing by 2, which is my new B value, that means that it's going to complete a full rotation in 180 degrees. So as kind of an example here, we have this graph, which first thing we can kind of see that this is in radians. But if I can identify midline, amplitude, and period, then I should be able to complete this graph. I will say that phase shift is trickier to come up with, so we might kind of hold off for now. So I can kind of see actually that I have a midline at -1. Okay, and I know it's a sine graph just because I'm starting at that midline here. So that's my midline, so that's my D value, so I know basically that D is going to be -1. My amplitude is going to be here, so that's a 3. It's the distance between my midline and maximum, or midline and minimum. So now I know my amplitude is 3. And then I'm just trying to figure out what my period is. This one's a little bit trickier to go from like a maximum to a maximum because these don't fall on even coordinates. So instead what I'll probably do is look here to say, okay, this appears to be completing in, 1 pi. Is my rotation. So if I want my period to be a pi, that means that I need sine of x to operate twice as fast as it normally does. So you can do it like this. You can say, okay, I want my period to equal 1 pi, and normally that's 2 pi divided by b. You can swap these if you really need to in order to see how this is exactly going to work. But let's actually keep the positions the same. So b equals 2 pi over 1 pi, or 2. You might not think to make it that confusing with this specific example, but if I have to make this like pi over 6, then all of a sudden that can become a little bit trickier. So it's nice to have a method. So I really just use the equation on top to say, okay, my new period needs to equal 2 pi divided by b, and then that helps me solve for what my b value is. So now I should know my final equation here. So this is going to be y equals 3 times the sine of 2x minus 1. Okay, and that is the equation of this graph if we are in radians on Desmos. So to round out this day, because I know there have been kind of a few disjoint things that we're going to be, hoping to complete, all I want us to do is to see if we can come up with the equations for these two graphs. And I did mention that they are just variations on sine of x with no phase shifts. And I believe, let me just double check, they're both in degrees. So I'll be completing these notes here and uploading them so that way you can kind of spot check. But today's not going to end with kind of a bunch of practice work at the end. I think we've done a lot of work up front. And tomorrow we'll probably get to practicing some of this. All right. Thanks, everyone.